Picture this. You are a NASA scientist tasked with designing a helicopter that will fly on Mars for the first time in human history, where no aircraft has gone before. How would you do it? Don't be fooled. It's not an easy task, but how could you beat impossible odds, overcome harsh conditions and time constraints to achieve this unprecedented feat? It sounds impossible, but in 2020, NASA succeeded in this mission. They launched the Ingenuity helicopter aboard the Perseverance rover to Mars to prove that it was, in fact, possible to fly a powered autonomous aircraft on another planet. Initially anticipated to fly 5 times, Ingenuity surpassed expectations and the mission proved to be a success as the helicopter is still working on Mars today. So, with all the challenges they've had to face, how did they do it? With that in mind, let's delve into the challenges faced by NASA's Ingenuity mission. Challenge 1. The atmosphere. Luckily, helicopters, unlike rovers, can fly, so traversing difficult terrain for Ingenuity is no issue for Martian discovery. The real question is, how can we get the helicopter to fly in the first place? Mars has a thin, carbon dioxide-rich atmosphere that is roughly 1% of the density of the Earth's. Therefore, the helicopter needs to work much harder to lift off the ground. To work around this, we can use 2 blades that spin in opposite directions to one another. Its elongated blades are driven by custom motors so that they can spin up to 2,800 rotations per minute, that is to say, very fast. These modifications will compensate for the lack of air particles to push against, helping to generate the lift needed for our helicopter to fly. Another issue we'll have to face is the low Martian gravity, which is around 1/3 of Earth's gravity. Lightweight materials such as carbon fibre blades and landing skids should be used to make the helicopter. Otherwise, it will be too heavy to lift itself off the ground. Because Ingenuity is so light, it can carry larger payloads relative to its weight, which is important for transporting scientific instruments such as cameras and microphones, relevant to its mission of Martian exploration. Now that we've tackled the Martian atmosphere, let's move on to the next hurdle, the climate. Challenge 2. Cold Martian nights. Although the helicopter can fly, it needs to stay warm, otherwise its components will freeze and won't be able to function. Martian nights are extremely cold, reaching temperatures of -90 degrees Celsius. So the question is, how can we help the helicopter survive these temperatures? Ingenuity uses an innovative solar panel atop the helicopter to charge its battery during the day, generating electricity from power from the sun so it runs remotely without being manually charged. Largely, it uses its energy to keep warm in the frosty weather. Most heating is needed to keep the battery warm at night, while other heaters warm up critical components before flight. For further insulation, the helicopter's body consists of multiple thermal barriers that trap in heat, including a gas gap filled with carbon dioxide. The helicopter's outer skin is made of dark mirror Kapton film that reflects heat from the sun. Most importantly, the helicopter should fly in the morning at around 11 AM local solar time, both to avoid the sun heating the cold atmosphere, which might cause high winds later, and to ensure the helicopters have enough charge to fly. As Ingenuity overcomes the challenge of extreme Martian temperatures, another complication arises. Challenge 3. Communication. Our helicopter can fly, but what next? We'll need to be able to communicate with our helicopter. To overcome weight restrictions, the engineers at NASA situated a base station electronics module on the Perseverance rover. Ingenuity speaks to the rover via a small antenna atop its solar panel. This antenna communicates with Ingenuity and orbiting satellites, sending data back to NASA Mission Control on Earth. Perfect! We can now talk to our helicopter. But wait, there's more. This method does have its limitations. Ingenuity must remain relatively close. And all operations must be undertaken within 100 metres of the rover, limiting the helicopter's reach and adding extra constraints to the mission. The good news is, now our helicopter has all the necessary parts and we're ready to let it fly on Mars. So, how did our helicopter do? Living up to its name, the Ingenuity helicopter is a testament to scientific achievement and has since been exploring Mars's greatest mysteries alongside the Perseverance rover. Ingenuity has flown an astounding 64 times, many times more than its 5 anticipated test flights. Scientists have even recorded the sounds of the helicopter's blades in flight, which NASA has published on their website for the public to hear. As we envision the future of Martian exploration, Ingenuity stands as a trailblazer. In future aerial craft, this technology will be remembered as the dawn of a new era in space exploration, one of tenacity despite the odds, so that one day humans may not only be able to set foot on Mars, but fly over its surface.